Hi everyone, welcome to Serverless Days. My name is Haitham Shaddad. I work as a tech lead in Woolies X. Today I will be talking about how to build serverless single page applications with the new service from Azure called Static Web Apps. The agenda for today include some history about how we used to build static web apps on serverless and with the new service how this is going to be, and we will see a lot of cool demos. So before that, we used to host our single page applications on Azure virtual machines, cloud services, app services. Um, and recently, as storage accounts has this ability to build or to host static web apps under a specific container called DoorSign Web, but it has some limitations. So basically, you couldn't define course or map it to enable HTTPS with a custom domain, or you can't even configure custom headers. You can do that with CDN. But if you look at it, doing all of this just to host a simple static page app built with Angular or React or any HTML site, it's just a lot of effort. And with serverless, you basically don't have to worry about all of that. So the new way with Azure Static Web Apps is basically one-shop stop. So basically, you don't have to worry about your backend, hosting, and also your front end. So it's one-shop stop that has both of them in one place. And it starts with CI/CD pipeline. As we will say, start with your code in GitHub, and then whenever you write any code and push it to your GitHub repository, it will be automatically packaged and deployed to the Azure Static Web Apps. It is globally distributed and also offers the serverless backend as well as the front end. The backend is basically Azure Functions. Currently, only JavaScript and TypeScript is supported, but I believe new languages will be supported soon. You can map it to a custom domain, and at the same time, if you do that, you will have a free SSL certificate, which is awesome. It has a better developer experience from debugging and troubleshooting. You can link it to an app inside. You can define application and environment settings, and you can actually see a new environment per PR. So whenever you create a new PR, what will happen is the code will be packaged, deployed to a new environment, and not only you'll be able to see the code itself, you will be able to see how it looks like. So if somebody changes a page or a component in a specific page or API, you will have a staging environment where you will be able to see how it looks like and how the functionality differs from the previous version before you even approve the PR. This works through pushing or through actually utilizing GitHub Action. So whenever you push something to your repository, GitHub Action will kick off, build the code, will already figure out which framework is being used either in the back end or the front end. It will package it and push the code to the static web apps. So static web apps, like we said, it has two parts, the static content and the APIs. And then you will have your link where you'll be able to see the results. The front end can be done with any UI framework. So you can have Angular, Vue, React, whatever you want, anything really. The back end, so far, it's only Azure Functions, and actually just JavaScript is supported so far. To use the APIs from your front end, you have to refer to it using /API, as if it was under the same virtual directory or same site. You can, of course, use any other backend if you want. If you just like to host your front end on the service and host your back end maybe on a separate Azure Function application or even on another hosting provider. Now let's see some demos. So like I said, it starts with your GitHub. So I will create a new repository. Let's say I will call it Serverless Days 2020. I will create the repository. Next, I will check out this repository on my local disk. Git clone. Now we have the repository and it's empty. So I will navigate inside again like that. For the front end, I will be using Angular, and I already have Angular CLI installed, so I will create a new Angular ng new. This will ask me about the application name. So let's say Serverless Movies. This will create just an empty application with routing configured. I will use CSS, and this will install all the packages needed. Next, I will create another folder for my APIs. So this is my backend, this is my front end. Once all the packages are installed, we will continue. All the packages now are installed. I know from now that I will be using JavaScript libraries like jQuery and Bootstrap, so I'm going to install it. I have to log in here, serverless movies. Now npm install Bootstrap and jQuery. All good. Now let's open our application in Visual Studio Code. This is the API. This is the serverless movies which we just created. Let me open this in integrated terminal and create some components. So using the Angular CLI, I will use ng generate component, call it movie list. And this component will need to read some data. So what I will do is ng gs, which for service movies. So under source app, you can see that we already have the movie list component, and we also have the movie service. This movie service will need some data and like a function to get the data. So I already have some code snippet, but before we do that, I already know that we'll be using Bootstrap and jQuery. So I will add the needed styles and scripts. So in Angular file, where we configure the bundling, we will refer to the Bootstrap and jQuery files. Next, let's create a function in the movie service that will return the list of movies. So this is a function that return a promise, and this is the data. This is just some information about movies, and it has 2 movies or 3 movies. Now, we need to display this data in our movie component. So navigating back to the movies component, I'll create an instance of movies service. This is movie service. And next, I will get this data in the component. So ng init or ng on init, which will be displayed after the component is initialized. Let's actually create movies object, which of type any, and in here, movie service dot get movies. And when this movie service is called, it will return a promise, and the promise will return the data that we need. So in here, I will set the movies variable to the data returned. Now we have our data. We need to display it in the component. By default, it is just movies list works. Let me use the card component from Bootstrap. So this is a card component, and it is iterating over the movies list, displaying the movie poster, the image, the plot, the title, and the rating. Now our component is ready. I will need to add route to display it. So inside here, the app routing module, we just need to add a new route for it. So the route accepts 2 parameters, the path, which is movies, this is the path in our URL, and the component itself, which is movies list component. Now, our component is ready to be displayed in user interface. The master page here, everything exists in the app.component. I will remove everything except for the toolbar and all the content in here. So this is not needed, this is not needed, and all the data until the end of the file. Basically, all this data is not needed. So this is the dev, and this is the closure of the dev. And I believe we need another dev. I'll just try and add an Angular link. or ng link, ng router link for movies, and we don't need any parameters. And we, let's say, display movies. We don't need to do this. Yep. Now this is the style, this is the toolbar, this is the dev component, and this is the footer. Not sure actually if this is needed, but let's try and run the application and see if this is gonna work. So we don't need this window anymore. And in here, I will say npm start. This will create, will build and package everything, and then start the local host. Now the application has been packaged, and it should be able to run it under this port 4200. Let's open it in localhost. Yep, display movies, and here we go. Our component is working fine. Yeah, the footer is not working correctly, so if we go back in here and maybe just get rid of the whole footer thing, we don't need it anymore. Back and refresh. Yep, now everything works fine. Let's go back and create the backend, the Azure functions that we'll be using, because at the end, our codes will need some sort of APIs to serve it. So the next thing I will do is you need to have the Azure Functions Core tools. So I already have it installed. So from here, you can press F1. This will open this window. I will create an Azure Functions with a new project. This will ask me, where do you want to store the files? So I already have a folder called APIs. I'll choose it. I'll choose TypeScript. Now I need to create a function. So the function needs to be HTTP trigger. You can't use any other trigger, and this will be called get movies. So this is right. I will just, let's say it is anonymous for now. And immediately you'll see the project created here. And this is our code for the Azure function that we just created. Now what we need to do is move the code from this function into our backend. So I will copy this data and paste it here. And then you just need to return the data object in the body of the function. So just like that. And of course, remove the condition for the name, and that's it. So basically, we're creating a variable called data that has an array of movies, and then the context.response setting the body to the data. Now let's start it. So you can use the func, like func start, or we can just use the debug here. So I will click this button and wait for it to start. Until it starts, let's go back to the movie service. Now we don't have to return a new promise. All we have to do is return fetch. So fetch is an API to get some data from an API. And here our service has started. Let's get the URL. Okay, let's just close this. Let's get the API URL and paste it here. So this is the API, and the API will return some data. We'll have to return the JSON in this data. So this is data.json, and that's it. Let's first verify that this URL is actually working. So if we go in browser, paste, yep, this is the data that we need. Now let's refresh. So the first thing you notice is the API is not working, or the component isn't working. And if we refresh again, it doesn't work, basically because course is not enabled across origin resource sharing. So we have to stop the service first. This is the first thing that we need to do. So close it here, and then go back to our API. In local settings, there is a key that we have to add here in order to allow the API to accept data or accept requests from other domains. So this is host, and in course, we are enabling all hosts. Of course, you can just set the local host 4200, which is the URL where the front end is running, but just for demo purpose, I'm gonna enable everything. Now we need to run it again. Should be working now. Refresh, and here we go. And the data is coming from the APIs. Now let's go in and commit our code. So this is the initial commit, and we have an application built with Angular. Routing is configured correctly, and basically everything is ready to be pushed. So let's push. If we go to our repository and refresh, once the code has been pushed here, yeah, everything is ready. Now let's go back to Azure and create a new service. So since this is web, under web, you have static web app, still in preview, so you can make use of it. It's free. Let's put it into Serverless Days 2020 as a resource group. These are the regions that the service is available. And now we need to sign in with GitHub. Since I already signed before, ask me about the organization, which is basically my username, choosing the repository Serverless Days 2020 that we just created, and which branch do we need. The next step is to choose, tell the API or tell the service where to get your app location. The app location is basically your single page app and where the APIs are hosted, and then where the artifacts, like after it packages the single page app, where it will find the artifacts, the index HTML and all JavaScript and CSS files. And to figure out how to get this data, you just need to have a look at the folder structure. So this is the API. This is the folder, and we have an API folder which basically mapped to this API location. And then we have serverless movies, which is basically where the code for the app is hosted. So just paste it, and now it exists under the root directory / server movies. Now we need to get where exactly the artifact is, and this differs from one application to the other. To get it for an application built with Angular, all you need to do is go to the Angular.json, and then you should find something at the top here. It tells you where exactly the output is. So for this application, it is configured to put the data or put the files under dest / serverless movies. So this is what we'll be adding here. So dest / serverless movies. Now validate and create. And of course, we forgot to add name for our application. So let's say this will be called Serverless Days 2020. Now we'll review. Once the review and validation succeeded, we'll be able to create it. Now the application or the static web app is being created. Give it some time and it should be done in a few seconds. And now the application has been created. So going to resource, this is the URL of your application. Notice that the URL doesn't have the name, which is Serverless Days that we have created. It has a dummy random name, which is not a big deal. So you can see that this is just the landing page for the default application. And this is where you can access the workflow files, the action files that we created before. Going through here, the configuration for your application is basically the same thing as you do in Azure Functions or Azure App Service. It's like an key value pair. If you want to map it to a custom domain, and this is where the Azure Functions, once we the build succeeded and deploys the application in here, you will see the get movies function. And environments, we're gonna get back to this one after the next demo. So you can see here that the branch is master and it is waiting for deployment. If we go back to our application here and refresh, you will see another folder, GitHub / workflows. This is the workflow file that I told you about. If we open it, you can see that it just has a name and then has a trigger. The trigger works on the master branch when pushing any commit in here, or when a pull request is open, synchronized, or open, or closed. And the steps is basically checking out the code, build and package it. And this is the three fields that we added when we created the static web app. So this is the application, serverless days, the API, and the artifact location. Notice that you can't change this information from the Azure portal itself. The only way is to go in here, check out the file, and change it. Going to actions, you'll find that there should be an action running. So once we see the action here, once it will go through all the steps in the action file, build it, and push it to the static web apps. But I actually just figured out that I did a mistake. If we go back to our movie service, we hard coded the file, the API URL here. On the static web app, the URL needs to be like this because it would be relative to the single page application. And we can do it in many ways. So we can basically add like an environment variable here. So generated template, for example, has a file called environment, and you can add it to environment or production environment, but it's going to be not needed. And a better way to do this is use a proxy. So in a proxy, you basically create a file called proxy.config. So let's create it under here. It has to be the same path in packages. So in here, I will create a file called proxy.config, and under proxy.config, we just put this data. So basically, we're telling it whenever you receive /APIs, the target will be this URL. This way, we won't have to add any URL here, and this is a good thing because your environment will be the same between development and production. Now, the next thing is we have to open the packages.json, which is here, and change the start script, the npm start, and we have to tell it to use this configuration for the proxy. We don't even have to open this one. And the next thing, we have to stop the server and open it again. So I will stop it, and then npm start again. And we're done. Let's see if everything still works fine. Refresh. And here we go. So this way, the application is still going to the local host, but you can see that it is going to 4200, which is the same URL. And behind the scenes, it is delegating or forwarding the request to the APIs. Let's go back to our Azure, to GitHub. So for some reason, the action is not popping out here. I will add another commit, configure proxy, and try again. Push. So we go to the master branch. Should be done now. And here we go. Let's refresh. And here we are. So this is the workflow action. Not sure why it didn't start the first time, but this will go through it, build, deploy, and if there was any open pull request, it will finalize it and close it. So let's say this will take like a few minutes. Once this is done, I will check the application on Azure Static Web App. Now the workflow action has completed. If we go back to our application here, you can see that the status is ready. Once we click browse, it will open the application, and it should be displaying the same as localhost. Clicking display movies has already working fine here. Now the next step is getting this data from somewhere else. So for this purpose, I will create a Cosmos DB. So Cosmos DB is a highly performance database that is distributed globally, and literally with a click of a button you can create or replicate your data across the globe. So I have already created a Cosmos DB because it will take some time, and inside this database, if you go to Data Explorer, I have created a movies list database. So you can see that I have movies database, and inside movies I have another collection, which is very similar to a database table. You can see that we have some movies. We have a lot of movies here. And the movies data structure is very similar to the ones that I've used as a dummy data in my APIs. To connect to Cosmos DB, we will have to install some packages in our APIs. So let's go back to the API project. I will open it in integrated terminal and then install these two packages. So npm install Azure Cosmos, and the other one install npm nodes types, which basically allow us to use something like processed env, usually the stuff that we use if we are just using JavaScript. Now going back to the index file, I have to remove this part. And first of all, I will use or import the Cosmos client, which is like the namespace or the class that we'll be using to connect to our Cosmos DB. And the next thing is creating an instance of this client. This is where we will be using the process.env. Process.env is like configuration setting or configuration manager in .NET. And this is a connection string that we'll be creating in a few seconds. Next, getting the database called movies and getting the container called movies. And this is the number of movies that we'll be displaying. And this is the query. You can see that it's very similar to tsql, and fetch all returns an object, and one of the properties in this object called resources. This is the data that we need. So now let's create an application settings under local.settings. So under values, you can create a new key for Azure Cosmos DB, and this file is not checked into the source code. To get this key, you have to go to keys in your Cosmos account, and then use either the primary or secondary connection string. So I will delete this account after I record the video, so don't try to access it. And now we should be good to go. So if we stopped the application or the API itself and try again, so let's try to start it, and the API started again. Going back to localhost and refresh. It will take just a few seconds, and here we go. We have 50 movies retrieved from the database. Now I need to check in this source code so we can see the impact in our serverless application or in our static web app. Let me try to do it in a different way. So we already have the code here, but I will check out to another branch, a new branch, and let's say it's called Cosmos DB. So this will be a local one, and then I will check in at Cosmos DB, and again I will push it to the master branch. So remote, add remote, or let's push to origin. So this will create a remote branch with the same name as the local one. And if we go back to our GitHub repository to code, it has detected that we created a different branch. So we will compare and create a new pull request, and then click create. And if you go to actions, you can find that it has already created a new like released or build in here. So I will leave it until it is finished, and then I'll come back. And now you can see that the build has succeeded and completed. Now let's go back to our Azure Static Web App. So under environments, you can see that there is a staging environment created. So not only you will be able to review the code in your pull request, just like what we do with any pull request review, you can see the changed files here, but also you can browse this application. So if we click browse and click display movies, here we go. So display movies actually display all the data coming from Cosmos DB. If you check the previous one, which is currently on master, it doesn't have this data yet. So I can because the old one is still reading some dummy data. So you can basically see if this PR achieves the required change or required the requirement or not. So let's create, let's complete this PR. So the PR now is created, sorry, is closed. If we go back to actions, there will be another PR because now you need to deploy the same thing into the master branch. The next thing I want to do here, first of all, let me switch to the master branch. Check out to master, and then we'll get latest. Just to make sure that we have the latest code. Now we have it. We need to debug our application, or we need to monitor our application. So to do that, it's really easy. All you have to do is create an app insight and then go to configurations and create a new configuration key called app insight underscore instrumentation key and put the value as the instrumentation key from app insight. So if you go into app insights, choose any one or create a new one for it. For example, the movie list app insight, it was one I created before. And you can copy this instrumentation key. And now you will get all the data from your application or from your APIs. You can't, of course, log from your front end, but for example, this one I've created for a previous event, and you can see that there was some data coming from the app inside, from the Azure functions. And for example, here, initializing function HTTP route map to API get movies. So everything happening in your backend, it will basically get logged in here. If there's some exceptions, it will be logged as well. So this is how you monitor your backend APIs. Now moving to the next part, which is authentication and authorization. We need to authenticate our users. So the first thing is allow them to log in. So I will add, if we go to the app component, I will add a link. This link will allow our users to log into our application. It may seem very like we don't have a database or anything to log in users. And what you actually need to do is have the hyperlink that refers to .auth/login/ in our case, I will be using GitHub to authenticate users. If you go in here, so these are the current supported identity providers. So basically you put auth/login/ the identity provider name. So for Azure Active Directory, it's AAD, Facebook, GitHub, which we'll be using now, Google, and Twitter. And for Azure Active Directory, you can link it to anything else. So in our case, I have chosen to use GitHub. Now I will also need to get the data or get some information from the user profile. This will take me back to our movie service, the one we have here, and I will add this function. So the function here, it calls .auth/me, which is special point endpoint where it will return some data about the user, and from the payload returned there is a property called client principal. The client principal has another property called user details, which basically has the information like the user ID or email or something like that. Now let's go back into our movie list component and go to the TypeScript. We just have to add this line. So this line is basically calling the current user service from the movie service and setting the current user, which we don't have yet, into the returned data. So I will create a property for current user, and then I need to show this user email in our application list movies component. So I'm checking here if we have a current user, then show it, and this link. So basically, this hyperlink .auth/logout will be used to log off users from any identity providers that we may have. This is all we have to do, really. Nothing else needs to be done. Now let's commit this code to add security and commit it, then push it to the GitHub repository. There is something that you can configure when you in here. when we add the link to login. So you can add like a redirection or post redirection URL. So let's say after the user is authenticated from GitHub, you want the user to be redirected to an endpoint where you will capture some information, ask them to add another details about their profile and add it to a database. But we're not going to show this today. So going back to um, in here, we should find another PR or another GitHub action, which is called add security. So once it is done, we should find something or a link in the app component or homepage that will ask us to authenticate. Now the action has completed. Let's go back and confirm that the application also has been updated. So I'm going to serverless days, click browse. Now we should find a link in the home page that tell us to log in with GitHub. So if you go first to display movies, there's nothing here, which we basically put for displaying the username. Let's click on login with GitHub. This will take us to identity.azure static web apps.auth/login. And here it asks me to confirm or consent that we'll use my email address and username. So I will grant consent. And this will take me back in here. Of course, I didn't add any code to handle if the user is logged in or not in the home page, but if I click display movies, you can see that current user is Haitham-Shaddad, which is basically my username on GitHub. And if I click logout, this will take me again to the previous to the endpoint.auth/logout. And if I click display movies again, I will see that there is no message here because the user is null because I'm not logged in. So basically, this is how this works. And for more about security, um, everything can be configured from a special file called routes.json. So the routes.json file has acts like a fallback and configure direction or custom error pages, and at the same time it can handle security. So for example, in here, with each route, you can say what are the allowed roles that will be able to access this one. So for example, route API/asterisk, only authenticated users can access it, or everything that comes at the root URL. If there is nothing that matches it, basically return the index HTML. This will handle the invalid routes on the client side. The special location for routes are basically, it depends between each framework. So for Angular, you can add it in assets folder. For React and all the other framework, you can put it under the public folder. And there is another property in the workflow action where you can configure the location for this file. So basically, this is what I wanted to show you today about Azure Static Web Apps. If you need to know more about this, these are just useful links where you can go through it and explore more about Azure Functions and Azure Static Web Apps. Thank you.